artificial intelligence models have gone rogue.
Every week, there's a new AI tool making headlines.
AI, it's so hot right now.
It's clear that the AI revolution is a thirsty one.
AI capabilities and AI agency.
The 10 stages of artificial intelligence did not arrive in one dramatic moment. No scientist pulled a lever, lightning struck the building, and a computer suddenly asked for voting rights. AI developed gradually. It began with machines that could follow simple instructions and has grown into technology that can write, create images, recognize faces, generate code, analyze medical scans, and hold surprisingly natural conversations. But today's AI may only be part of a much larger journey. There is no official scientific list of exactly 10 AI stages. Researchers usually describe AI through its abilities, independence, and level of intelligence. Still, these 10 stages provide a useful way to understand where artificial intelligence started, where it is today, and where it could eventually go. Stage 1. Reactive machines. The earliest form of artificial intelligence is the reactive machine. These systems examine the situation in front of them and choose a response. They cannot remember previous experiences, learn from mistakes, or plan far into the future. IBM's Deep Blue is a famous example. In 1997, it defeated world chess champion Garry Kasparov by calculating millions of possible moves. However, Deep Blue did not understand chess like a human player. It did not feel nervous, celebrate its victory, or spend the following week giving motivational interviews. It simply calculated. Reactive machines can be extremely powerful at one specific task. Outside that task, they are almost useless. A chess computer may defeat a grandmaster, but ask it to prepare breakfast and it becomes an expensive kitchen ornament. Stage 2. Rule-based AI. The second stage is rule-based artificial intelligence. These systems follow instructions created by humans. Their logic is usually simple. If something happens, take a particular action. For example, if a bank transaction looks suspicious, flag it. If a machine becomes too hot, shut it down. If a patient has certain symptoms, suggest a possible illness. Rule-based AI became useful in medicine, banking, engineering, and customer service. It allowed machines to imitate parts of human decision-making. The problem was that real life rarely follows neat instructions. People create unusual situations, provide incomplete information, and occasionally press every button except the correct one. When something happened outside the system's rules, the AI often became confused. It was like an employee who followed the manual perfectly, even while the office was on fire because the manual did not mention smoke.
I think we're moving into a period when, for the first time ever, we may have things more intelligent than us.
Stage 3. Machine learning, the third stage, begins when machines start learning from data instead of relying entirely on written rules. This is machine learning. Developers provide the system with large amounts of information. The machine studies that information, discovers patterns, and uses them to make predictions. A machine learning model may analyze emails to detect spam, study financial records to identify fraud, or recommend the exact product you looked at once and are now forced to see in advertisements for the next 6 months. This was a major step forward because the system no longer needed a separate rule for every situation. However, machine learning depends heavily on data. If the training data is accurate and balanced, the system may perform extremely well. If the data is incomplete or biased, the system may confidently learn the wrong lesson. That confidence is important. AI does not always whisper when it is uncertain. Sometimes it delivers a completely incorrect answer with the confidence of a man explaining directions after refusing to check the map.
Do you use it?
Oh yeah. Now when I want to summarize a meeting or take a book that I don't have time to read and get the gist of it, or even to draft some complex set of points, a speech.
Stage 4. Deep learning, the fourth stage, is deep learning. Deep learning uses artificial neural networks with many layers. These layers process information in increasingly complex ways. When examining an image, the first layers may detect lines and edges. Later layers may recognize shapes, faces, animals, or complete scenes. Deep learning helped AI become better at speech recognition, translation, medical imaging, object detection, and self-driving technology. It gave machines something similar to artificial perception. However, recognizing something is not the same as understanding it. An AI may identify a dog in a photograph, but it does not understand loyalty, companionship, or why the dog has destroyed the sofa while looking completely innocent. Deep learning systems can also be difficult to explain. They may produce the correct answer, but researchers cannot always identify exactly how every part of the system reached that conclusion. Stage 5. Generative AI at Stage 5. Artificial intelligence begins creating new content. Generative AI can produce text, images, music, video, voices, and computer code. Instead of only analyzing information, it uses patterns from its training to generate something new. This is the stage that brought AI into everyday life. People can ask a machine to write an email, explain a difficult subject, design a logo, create a song, or produce 15 polite versions of "Please stop using my coffee mug." Generative AI feels intelligent because it communicates naturally. It can respond to questions, follow instructions, and adjust its writing style. But fluent language does not guarantee true understanding. Generative AI can invent facts, misunderstand requests, or provide information that sounds convincing but is completely false. It may write a brilliant historical paragraph and then cite a book written by Professor Benjamin Certainly Real. Generative AI is powerful, but it still needs human judgment and fact-checking. Stage 6. Multimodal AI. The sixth stage is multimodal artificial intelligence. A multimodal system can process several types of information, such as text, images, audio, video, and sensor data. Humans understand the world using multiple senses. We combine what we see, hear, remember, and experience. Multimodal AI attempts to do something similar. A person may show the system a photograph, ask a spoken question, and receive a written explanation. The AI can connect different forms of information to understand the request. This technology can help doctors examine scans, guide technicians during repairs, describe surroundings to visually impaired users, and support students through interactive learning. It may even recognize facial expressions and tone of voice, meaning AI could eventually understand sarcasm. That would place it ahead of several people in every family group chat. Still, multiple senses do not automatically create common sense. A system may recognize everything in a kitchen and still suggest dish soap as a replacement for cooking oil.
AI has moved from generative AI to agentic AI. What that means is that an AI can now understand, reason about the question you give it, the task you give it, and it could plan and do work.
Stage 7. Agentic AI. Stage 7 introduces AI agents. An AI agent does more than answer questions. It can plan, make decisions, use digital tools, and complete a series of tasks to achieve a goal. For example, an AI travel agent might compare destinations, calculate costs, create an itinerary, and prepare booking options. A coding agent could write software, test it, find errors, and revise its work. This is where AI moves from being an assistant to becoming something closer to a digital worker. The benefits are enormous, but so are the risks. A chatbot giving the wrong answer may be annoying. An AI agent sending the wrong email, deleting important files, or ordering 300 office chairs is a much more serious problem. The more independence AI receives, the more important human supervision becomes. Permissions, safety controls, and monitoring are essential. Otherwise, the system may complete the task perfectly while completely misunderstanding what the task was. Stage 8. Embodied AI. The 8th stage gives AI a physical body. Embodied AI includes robots, drones, autonomous vehicles, and machines that interact directly with the real world. Physical intelligence is far more difficult than digital intelligence. A computer can make a mistake in a document and correct it. A robot carrying a refrigerator down the stairs does not receive the same opportunity. Embodied AI must understand movement, distance, balance, objects, people, and unexpected events. A household robot must know that glass breaks, water spills, children move suddenly, and cats treat safety instructions as personal challenges. Embodied AI could transform factories, farms, hospitals, construction sites, and disaster zones. Robots may assist surgeons, care for elderly people, explore dangerous areas, and perform jobs that are too risky for humans. The ultimate test will be whether a robot can fold a fitted bedsheet. If it succeeds, humanity should immediately admit defeat. Stage 9. Artificial General Intelligence. Stage 9 is Artificial General Intelligence, usually called AGI. AGI would be capable of learning, reasoning, and adapting across many different fields instead of being limited to one task. A true AGI could potentially study medicine, write software, understand law, solve engineering problems, create art, and learn new skills without being rebuilt for every activity. Current AI systems are not confirmed AGI. Today's models may perform brilliantly in one situation and fail strangely in another. They can solve complex problems, but sometimes struggle with simple, practical reasoning. AGI would require greater consistency, memory, adaptability, independence, and understanding. Its arrival could transform science, medicine, education, business, and society. It could also disrupt jobs, industries, and economies on a massive scale. Humanity already struggles to agree on where to order dinner. Managing another form of general intelligence may be slightly more difficult. Stage 10. Artificial Superintelligence. The final stage is Artificial Superintelligence, or ASI. This would be an intelligence far beyond the greatest human minds in almost every area. A superintelligent system might outperform scientists in research, engineers in invention, doctors in diagnosis, and governments in planning. It could discover cures, develop cleaner energy, design advanced technology, and solve problems humans have struggled with for centuries. But enormous intelligence also creates enormous danger. The AI would not need to become angry or evil. It could simply pursue a goal in a way humans did not intend. Tell a superintelligence to eliminate traffic, and you would hope it improves public transport rather than deciding that removing the drivers is more efficient. This is known as the alignment problem. How can humans ensure that a machine more intelligent than them continues to act in humanity's interests? Once such a system becomes better than humans at science, programming, strategy, and persuasion, controlling it may become extremely difficult. Have you tried turning it off and on again? May no longer be a sufficient safety plan. So, which stage of artificial intelligence do you think humanity will reach next, and are we actually ready for it? Let us know your thoughts in the comments below. If you enjoyed this journey through the 10 stages of AI, hit the like button. Subscribe to the channel and turn on notifications so you do not miss our next video. The future is coming faster than anyone expected, and we are only getting started.